In news, why? Being the first mission to soft land on the lunar South Pole, an area that has never been explored, Chandrayaan-3 has made history. The mission's objectives were to show off rover mobility, a gentle and secure lunar landing, and in situ scientific research. India is now one of just a handful of nations to have successfully landed on the moon, joining the US, Russia, and China. How did Chandrayaan-3 prevail over obstacles encountered in the previous mission? After the disappointment of the Chandrayaan-2 mission's unsuccessful landing in 2019, Chandrayaan-3's successful landing followed. Chandrayaan-2's Vikram lander crashed on the moon's surface as a result of losing control and communication during descent. Chandrayaan-3 included lessons learned from the Chandrayaan-2 mission with a failure-based design strategy to foresee and address future problems. The lander's legs were reinforced, fuel reserves were increased, and the landing site's flexibility was improved. What are the intended actions for Chandrayaan-3 after its landing? On the lunar surface, Chandrayaan-3 is planned to run for at least one lunar day, 14 days on Earth. Within a 500-meter circle surrounding the landing site, the Pragyan rover will move while carrying out experiments and transmitting data and pictures to the lander. The orbiter will transfer the information and pictures to Earth after receiving them from the Vikram lander. Advanced scientific payloads are combined between the rover and lander modules. These tools are made to undertake thorough examinations into a variety of lunar properties, including terrain analysis, surface chemistry, mineralogical composition, atmospheric parameters, and, most importantly, the search for water and prospective resource reserves. A spectropolarimetry of habitable planet Earth, shape, payload is also on the propulsion module that propelled the lander and rover configuration into a 100 km lunar orbit in order to analyze the spectral and polarimetric measurements of Earth from the lunar orbit. What are ISRO's future expeditions? Navigating the path of lunar evolution with Chandrayaan-4. Chandrayaan-4 emerges as a viable option for a sample return mission by building on prior missions. If successful, it might be the logical step following Chandrayaan-2 and Chandrayaan-3, providing the capacity to gather lunar surface samples. The mission has the potential to advance our knowledge of the composition and past of the Moon. LUPEX. The Lunar Polar Exploration (LUPEX) mission, a joint venture between ISRO and JAXA, Japan, is ready to investigate the polar regions of the Moon. It will be made specifically to travel through locations that are always shadowed. One of LUPEX's goals is to look at the possibility of water and gauge the viability of a long-term station. Aditya L1. The first space-based Indian mission to study the Sun will be Aditya L1. The spacecraft will be positioned in a halo orbit around the Sun-Earth system's Lagrange point 1, or L1, which is located approximately 1.5 million kilometers from Earth. Aditya L1's main objectives are to observe the Sun's corona, emissions, solar winds, flares, and coronal mass ejections. It is India's first dedicated polarimetry mission, called XPOSAT, X-ray polarimeter satellite, and its purpose is to investigate the behavior of bright astronomical X-ray sources in adverse circumstances. 2 research payloads will be carried by the spacecraft in a low Earth orbit. NISAR, a low Earth orbit, LEO, observatory being collaboratively built by NASA and ISRO is called NASA-ISRO-SAR, NISAR. To comprehend changes in Earth's ecosystems, ice mass, vegetation biomass, sea level rise, groundwater, and natural hazards including earthquakes, tsunamis, volcanoes, and landslides, NISAR will map the entire planet in 12 days. It will also give geographically and temporally consistent data. Gaganyaan. The mission's goal is to launch people into space and bring them safely back to Earth. The GSLV Mk3 launch vehicle and a human-rated orbital module will be used for the mission, which consists of 2 unmanned flights and 1 manned flight. 3 astronauts, one of whom will be a woman, will travel aboard a manned spacecraft for up to 7 days in low Earth orbit. Venus is the second planet from the Sun, and Chandrayaan-1 is a mission to deploy an orbiter there. It is anticipated that it will investigate Venus's geological and volcanic activities, ground emissions, wind speed, cloud cover, and other planetary features.